Now go to some example. Look at A. Cosine theta plus sine theta squared plus cosine theta minus sine theta squared equals 2. We start with the left-hand side. For A plus B squared, we know that it's A squared plus 2AB plus B squared. So we expand this binomial square. We got cosine square theta plus 2 cosine theta sine theta plus sine square theta. For this part, we got cosine square theta minus 2 cosine theta sine theta, then plus sine square theta. Combine like terms, cancel out. We got 2 cosine square theta plus 2 sine square theta. Then we take a 2 out. We got the cosine square theta plus sine square theta. That is 2 times 1 equals 2. Equals right hand side. Finish proving. For B, we will do the same thing. So for 2 sine theta squared, that's 4 sine square theta. These two multiply times 2, we got 12 sine theta cosine theta. Then for 3 cosine theta squared, that's plus 9 cosine square theta. You just need to remember A plus B squared equals A squared plus 2AB plus B squared. So for this one, we got 9 sine square theta. Then for these two, multiply times 2, that will be negative 12 for sine theta cosine theta. The negative 2 cosine theta squared, that's 4 cosine square theta. Then you can combine like terms. This is gone. For sine square theta, you got the 13 sine square theta. For cosine square theta, you still get the 13 cosine square theta. That's 13 equals right hand side. That's we finish proving. Let's go to C. For the C part, we're working on this fraction first. So we get started from left hand side. We got the 1 minus cosine theta times, put the 1 over 1. We got the cosine theta. Then cross multiply, we got the cosine theta plus 1. This is multiplication, so I can put the over 1. I will get the cosine theta as a denominator. For 1 minus cosine theta, this is cosine theta plus 1. Basically, that's 1 plus cosine theta. So we can do A plus B times A minus B. Conjugate multiply. We got A squared minus B squared. So we got the 1 minus cosine square theta. That is the sine square theta over cosine theta. Now you need to analyze this trig expression on the right side of this trig identities. We need a tangent theta. We know that sine theta over cosine theta, that's tangent theta. So for sine square theta, I can write down sine theta times sine theta. And for this part, that's a tangent theta. So you got the tangent theta times sine theta equals right hand side. So we finish the proof. Now let's go to D. Still, when you have this operation, I will work on this addition of fraction first. So left-hand side, that's 1 over 1. We got the sine theta. Numerator will be sine theta plus 1. For these trig expressions, we need to do the factor so that we can reduce. We try to factor this one, we can reduce with this fraction. Therefore, I got sine theta, that's common factor, that's 1 minus sine theta. Then we put over 1. We know that sine theta, 1 as a denominator, 1 as a numerator, reduce. So we got denominator, this is a 1, so basically it's 1. Numerator, I got sine theta plus 1 times 1 minus sine theta. For sine theta plus 1, we count as 1 plus sine theta. Then we got a plus b times a minus b, that's conjugate multiply. We got a squared minus b squared. Therefore, I got 1 minus sine squared theta. That will be cosine squared theta. It's the right-hand side, so we finish the proof. Here's the rule. When you have fraction, that's rational expressions, we need to factor each expression so that we can reduce them. Now let's go to E. Still, we need to get started from the left-hand side. Change everything into sine and cosine. So we got 1 over cosine A minus cosine A. Then we do operation of fraction. Denominator multiply, that's cosine A. Then do cross multiply, we got 1 minus cosine square A. 1 minus cosine square A, we know that is a sine square A over cosine A. Analyze the trig expressions on the right side. We got tangent A over here. Therefore, for sine square A, I change into sine A times sine A. Then for cosine A, this one, we create the tangent A times sine A. That's equals to right-hand side, so we finish proof. Now let's go to F. Here's the signal for you to do conjugate multiply. So we get start from left-hand side. We know cosine theta, denominator is 1 minus sine theta. We do conjugate multiply to the top and the bottom. That is 1 plus sine theta. 1 plus sine theta. For these two, we got 1 minus sine squared theta. Therefore, we got cosine squared theta as a denominator. Before you do this conjugate multiply, remember that cosine squared theta is our expected value. So we got this part. Then we bring down the top cosine theta times 1 plus sine theta. Then we reduce. We got the cosine theta as a denominator. Therefore, I got 1 plus sine theta over cosine theta. When you analyze the right side of this trig identities, we need to separate this fraction. So we got 1 over cosine theta plus sine theta over cosine theta. Then we got secant theta plus tangent theta. That's equals to right hand side. So we finish proof. Now let's go to G. First of all, you need to change everything into sine and a cosine on the left side. So we get started from the left side, change everything into sine and a cosine. For cosine alpha, 1 minus tangent alpha, that's a sine alpha over cosine alpha, plus sine alpha over 1 minus, for cotangent, that's a cosine alpha over sine alpha. Now we're working on the denominator, this operation. To the top, still cosine alpha. Denominator, we do cross multiply. Denominator multiply, that's cosine alpha. Cross multiply, that's cosine alpha minus sine alpha. Then plus sine alpha stay at the top. Denominator, we do operation of addition. That will be sine alpha as denominator, because 1 times sine alpha. Then we do cross multiply. You will get sine alpha minus cosine alpha. This time, since we have a clear division line, we can jump. Make a denominator jump to the top. We got cosine alpha minus sine alpha, and then cosine square alpha, plus this part, we have sine alpha minus cosine alpha, then sine square alpha. Let's check a denominator, cosine alpha minus sine alpha and sine alpha minus cosine alpha. They are opposite to each other. We know A minus B and B minus A are opposite to each other. So I can put the negative sign before B minus A so that we can get the A minus B. In this case, I can put the negative sign before sine alpha minus cosine alpha, so that we can get the cosine alpha minus sine alpha. And we got the same denominator, so we can put this together. Denominator is cosine alpha minus sine alpha. Numerator, we put cosine square alpha minus sine square alpha. For cosine square alpha minus sine square alpha, this is dose factoring. A squared minus B squared equals A plus B times A minus B. Therefore, for cosine square alpha minus sine square alpha, I can factor like cosine alpha plus sine alpha times cosine alpha minus sine alpha. Then we can reduce these two and get cosine alpha plus sine alpha. That's the right hand side. So we finish this proof. Let's go to H. For H, when you have 1 plus cosine theta, that's conjugate multiply, you are supposed to get sine square theta as a denominator. Therefore, we get starting from left hand side, and we will do the conjugate multiply for 1 plus cosine theta. That's multiplied by 1 minus cosine theta, top and bottom. We need to break down this part. That's 1 plus cosine theta over sine theta. For these two, we know that 1 minus cosine squared theta. So 1 minus cosine squared theta, that's a sine squared theta. Then we got the sine theta times 1 minus cosine theta. Never do distributive property during the process of verifying trig identities, because we need to reduce the factor. Then I add sine theta, top is 1 plus cosine theta. Now we can reduce. Here's 1, this is sine theta. We got the same denominator, both sine theta. Therefore, I can put this together. That's sine theta. Top, I got the 1 plus cosine theta plus 1 plus cosine theta. Now we can combine like terms. This is gone. We got the 2 over sine theta. That is 2 times cosecant theta equals right hand side. Now let's go to I. We got a signal for conjugate multiply. So we do that separately. We have left hand side equals 1 minus cosine theta. We need to do conjugate multiply 1 plus cosine theta. Top will be sine theta times 1 plus cosine theta. In your mind, remember for these two, the expected value both is sine square theta. That's our goal. So for these two, we got the 1 minus cosine square theta. That give to you sine square theta. So go to the second part. We have minus 1 plus cosine theta. Then we do 1 minus cosine theta, top and bottom. Bring down this part is the sine theta. So we got 1 minus cosine square theta. That will be sine square theta. Then to the top, that's a sine theta times 1 plus cosine theta. Go to this part, we got the same denominator, that's sine square theta. Top part, that's sine theta times 1 minus cosine theta. Reduce, we got the sine theta. Since we have the same denominator, when we add together, we got the same denominator, that's sine theta. To the top, 1 plus cosine theta. Be careful for this side. You see this is a negative sign. When you have negative sign and this one is a binomial, you have to put the parentheses. So minus 1 minus cosine theta. Then you do distributive property. You will get sine theta 1 plus cosine theta minus 1 plus cosine theta. Then you combine like terms. This is gone. You got the 2 cosine theta over sine theta. Cosine over sine, that's cotangent. So you got the 2 cotangent theta. That is the right hand side. So we finish this proof. Let's go to J. Same thing. This give you signal you got to do conjugate multiply. Then expected answer will be cosine squared theta as a denominator. So left-hand side equals 1 over 1 minus sine theta. You have to do conjugate multiply, top and bottom. That's 1 plus sine theta, 1 plus sine theta. Then I add 1 plus sine theta. You have to do conjugate multiply. That's 1 minus sine theta. 1 minus sine theta. Here's 1 times. Then working on conjugate multiply, this part is 1 minus sine squared theta. For these two, we got the 1 minus sine squared theta. 1 minus sine squared theta, that's cosine squared theta. Top, I got the 1 plus sine theta. Then I add cosine squared theta. We got the 1 minus sine theta. Therefore, since we got the same denominator, I add to the top. I got the 1 plus sine theta plus 1 minus sine theta. Combine like terms, reduce. You will get 2 over cosine squared theta. That is 2 times secant squared theta. That's equal to right hand side. So we finish the proof.